Hello friends, welcome to StudyCell. In this video, we will make an IoT-based ESP32 Smart Timer using Firebase. In my previous project, I have already made a smart timer with AP mode for local control. But in this video, we will try to connect Firebase so that you can control the same timer from anywhere in the world. Now here, instead of creating new hotspot, ESP32 directly connect to a Wi-Fi network. If you connected with the same Wi-Fi network, then you can also open the dashboard with this simple URL and monitor the live feed from ESP32. If the time is wrong, you can just go to RTC tab and tap this button to sync the RTC module with your mobile time. And from the tool we can reset the ESP32 or do the factory reset, and from the home tab we can also control the relays with these buttons, and if we control the relay with manual switch we can monitor the real-time feedback on the dashboard. And if required, you can always schedule the on and off time from this dashboard. Now if you are far away connected with the different network, still we can control this timer with Firebase. First, we have to log in with email and password. After that, here we can monitor the current state of the ESP32. Now, as we are using free plan, so to limit the number of requests, you have to do manual refresh to see the current state of the ESP32. And we can also sync the RTC module from the Firebase with this button. Now, let me quickly set the on and off time. You can also select the weekdays. Now, I will save the time. On the OLED, you can see the time saved successfully. Now the timer activated, the relay will automatically turn on as per the predefined time. Here you can see the lamp turns on. Now to get the feedback, I just have to press the refresh button. The ESP32 send all the details to Firebase dashboard. Now let me turn off the complete supply. ESP32 do not have any power supply right now. Now in this time, if I do the refresh, ESP32 can't send any response to Firebase dashboard, so the Firebase will wait for 10 seconds. After that, it will show the status offline. Now let me turn on the supply again. As the EEPROM activated and the timer is on, the lamp automatically turns on. Then ESP32 is trying to connect with the Wi-Fi, and if it is connected, the blue LED will stop blinking. And now if I do the refresh, as the ESP32 connected with the Wi-Fi, here you can see now it is showing online. Now the relay will automatically turn off as per the predefined time. So if Firebase send any request to ESP32, only then ESP32 send response to Firebase. Now we can also control the relay with this button. Let me turn on the relay. Now let me turn off the relay. So in this way we can easily control the timer from anywhere in the world through internet. And here you don't have to create the real-time database manually. After programming the ESP32, it will automatically create the database structure for you. During the video, I will share the complete code and all the required details. So after watching the complete video, anyone can make this IoT-based timer. So without any further delay, let's get started. This video is sponsored by Altium, a world-class PCB design software trusted by many of the biggest electronic companies. The user interface is so simple, you can easily design any complex PCB in Altium. It brings together PCB design, MCAD, data management and teamwork. It also provides centralized cloud storage, automatic backup and many more powerful features. And if you are a student, you can also enroll Altium Student Lab for free to get access Altium software and online PCB design courses. After completing the course, you will also receive a certificate of completion from Altium. There are many other key benefits, so I highly recommend checking out the Altium Student Lab. You will find a link in the description. Just enroll using your university email ID. It's a great opportunity for students and a great initiative from Altium to help you grow your skill in electronics design. This is the circuit for this project. This OLED is optional. For manual control, you can either use latch switch or push button. Just connect it across the D13 and ground, and you can either use active low or active high relay module. We can configure it from the Arduino sketch. Now for this project, I have made a complete circuit on this 0 PCB with the help of this PCB layout. In my previous video, I have already explained how I have made the PCB from the layout. Link is in description. Now let me connect the ESP32 with my laptop to upload the code. Now this is the source code and this is the UI file for the web dashboard, and this is the database rule. You can download all these files from our website iotcircuithub.com. Just visit the article. You can find the link in the description. Then you can download all the files from these buttons. Now after downloading the code, we have to quickly configure the Firebase console for this project. So I will type Firebase console, then click on this Firebase console Google link. You must have a Google account. Here I have already logged in with the Google account. Otherwise you have to sign in. Now I will click here to create new project. I will give the name ESP32 Timer version 3. You can give any other name. Click on continue. I will disable the Gemini. Continue, then disable analytics, then click on create project. It may take some time. Now click on continue. First we will create our authentication email ID and password. So I will go to security, select authentication, then get started, select email ID, password, enable this option, click on save. Now I will go to user tab, click on add user, enter any email ID which you will use to log in the Firebase dashboard, then enter a password, then click on add user. After saving, we got the UID. I will just copy this UID, then open the database rules. Now here you can define two rules. With the first rule, any authentication user can log in the Firebase. With the second rule, only this user can access the dashboard. So I will select the second rule. So I will enter this specific UID for that user. So only this user can log in. Now I will go to Firebase console. Now we will create the database. So select database and storage. Then select real-time database. Click on create database. Select the nearest location. Next, start in test mode, enable. So here you can see our database created. Now I will go to rules tab. Then we have already modified the rules. I will just copy this and paste it here. So after that, only this UID can access the dashboard. Then click on publish. So our database created, and the structure will automatically create by the ESP32 after uploading the code. So now we will create the web app. So I will go to setting, then general, then scroll down, click on this web icon. Then we have to give a name for this web app. You can give any name, then click on register app. So now we will get the API for this project. Continue to console, and here we will get all these details we required for the web dashboard. Now we can move to the coding part of this project. So I will just open the Arduino sketch with Arduino IDE. Now for this project, I have used this version of the ESP32 board, and you need to install all these libraries and related dependencies. After that, here I have to enter the Wi-Fi name, then the Wi-Fi password. Now this is the host name. It also acts as a device name. You can change this name as per your requirement, say water pump, garden pump, but don't use any space or special character in this name, as we are going to use this host name to create the URL for STA and also use it to create database structure in Firebase. Now after the host name, we have to enter the API key. So I will go to Firebase account. So under the setting, if I go to general, then here you will get the API key. I will just copy the API key, then paste it here. Then I have to enter the database URL. So again, I will go to Firebase, then real-time database. I will just click here to copy the URL, go to Arduino IDE, paste it here. Then I have to enter the email and password we have created for the authentication. So if I go to authentication, here you can see this is the email ID. So I will just go to Arduino IDE, enter the email ID and the password. After that, you can change this flag according to your circuit. Here I am going to use active high relay module, so I have made it false. Then I am going to use latch switch, so I have also made this flag false. For the push button, you have to make it true. Then I will use EEPROM to save the schedule, so I have made it true. And I also need the serial debug message, so I have made it true. Now these are the GPIO pins I have used for this project. Then these are some time interval related to Firebase and Wi-Fi connection. First, I will recommend you to upload the complete code, then test it. If everything works fine, then if you want, you can play with these delays. Now these are the cloud comments. Here we are using free plan of the Firebase, so we don't want to send continuous requests to Firebase. It will exhaust the free limit. Now to minimize the amount of data, here we are using integer instead of the string. So if you want to refresh the Firebase dashboard, we will send 1 to ESP32. Then ESP32 will send complete JSON object to Firebase. If required, Firebase will request data and ESP32 will send a JSON object. And this is the parameter for the OLEDs. Now let me upload this case to ESP32. So I will select the board as do it ESP32 dev kit and select the proper COM port, then hit the upload button. If you go through the code, you can easily understand. Still, if you have any query, you can always let me know in the comment section. I will try to explain the complete code line by line in the same article. You can find a link in the description. Now after uploading the code, I will open the serial monitor with this broad red. Now I will just reset the ESP32. Here you can see it trying to connect with the Wi-Fi. After connected with the Wi-Fi, it will give me the URL for the STA. I will just copy this URL. Then I will open it in a browser. Now if you connect with the same Wi-Fi, we can also open this dashboard with this URL. Here we can see the current time. We can set the schedule. We can also configure the RTC module with the browser time. Now let me go to the Firebase. So here you can see it automatically created the structure after it connect with the Firebase. So I will just delete the complete node just to show you it will create automatically. Now again I will restart the ESP32, and after it connect with the Wi-Fi, here you can see it will automatically create the complete structure. Now from this action node, I can control the ESP32. So if I go to the code, with this cloud command, we can control the ESP32 from Firebase. So here you can see if we send 3, the relay should turn on. So let me enter 3, then hit the enter. I have connected the LED, it turns on. Now I will enter 4 to turn it off, and we can also monitor the status on this web dashboard. We can also control it from these buttons if we connect with the same Wi-Fi. So after testing the Firebase connection, now we can deploy the complete web dashboard in the Firebase hosting. So let me go to the UI folder. These are the files we have to deploy. Now before that, we have to configure the script.js. So let me open it with Notepad++. You can also open it with Notepad. Now first we have to update this Firebase credential. So I will just go to Firebase, then setting, general, then from here scroll down. I will copy all these details, then I will paste it. After that, if you have modified the device name, then you also have to change the device name here under the global variables. As I said in the code, the host name must be same with this device name, otherwise you cannot able to control the relays from the web dashboard. After checking these two things, I can save the script.js. Now I will deploy it. For that, I have already published a tutorial in my website IoT Circuit Hub. I will share the link in the description. Now to deploy it, first we have to open the command prompt. Then first we have to check if the Node.js is installed. So I will just copy this, go to command prompt, paste it. So it is showing the version. So the Node.js is installed. Otherwise, just go to this link, install it. After that, I will copy the next command and paste it here. Hit enter. It may take some time, so please wait. After that, I will copy the next command, Firebase login, then go to command prompt, paste it, hit the enter. Now as I have already logged in with the Google account, here you can see I have already logged in with this email ID. So it's showing the email ID. In your case, if you do it first time, a pop-up may open. You have to log in with the same Gmail ID you have used with the Firebase. Now after login, again I will go to the web page for the next command. Now we have to change the directory where we kept all the file. You have to keep all these 3 files in the same folder. I will copy the link, go to command prompt, cd to change the directory, then paste the complete path. Next, I will just copy this command, paste it, hit enter, then enter Y. Here I am going to use existing project, so I will select existing project, hit enter. Now we have to select the project name, so this is our project name, ESP32 Timer version 3. Hit enter. Now we have already changed the directory and all the files are in this directory, so I will enter dot, then enter, then I will enter no, n, enter, again type n, hit enter, again type n, hit enter. Now we have to deploy it. Again we have to copy the last comment, Firebase deploy, to deploy all these files. Now with this comment everything will be deployed to Firebase Hosting. So deploy complete, and it also gave me the URL to access the dashboard. So I will just copy the URL, go to browser, paste the URL, hit enter. Now enter the authentication email ID, then the password. So this is our dashboard. From here we can see the current time. We can also see the current time here. So we got the same time. Currently the device is online. We can set the time from here. Now let me turn on the relay. So you will see all the activity from here. You can see the relay turns on. Now let me turn it off. The relay will be turned off. To see the all current status, we can just click on refresh to update all these details from the ESP32. Here you can see I have connected the relay module with the PCB. Now let me turn on the supply. First ESP32 will try to connect with the Wi-Fi, and once it connected, the blue LED will constantly glow. So this was the URL for the Firebase, and now we have to log in to Firebase dashboard with email ID and password. So currently the device is online, so it is showing online, and this is the current device status. Now from this dashboard, if you want to see the latest data from ESP32, we just have to refresh the dashboard and we can see the current time, date, all the details. Let me turn on the relay. Now the relay is on, but here it is showing relay off, as the ESP32 do not send data continuously to the Firebase dashboard. If we request the latest data from ESP32, only then ESP32 send the data and we can monitor it on this web dashboard. As we are using free plan, so we have to take care of the request limit under the free plan. Now from here we can set the timer. So this is a very useful project. If you find this video helpful, then please hit the like button. In upcoming videos I will try to add more features. If you have any idea, you can also let me know in the comment section. Don't forget to subscribe for more such videos. Thank you for watching. Have a great day.